Daddy, what is there? Daddy, what's there? Daddy,
Hello, friends. Welcome to the demo on data science and generative AI. So just want to get a quick glance whether you guys are attending the demo for the first time or have you attended a previous demo? Can you just put a quick poll on the chat? If it is the first time, just write first time. First time. Okay. All right, all right, all right. Very good, very good, very good, very good. Because there are a couple of things which I will be talking, so I wanted to understand whether you're first time or already attended my demo. Anyway, so let me quickly share my screen. Because for the first time participants, I would generally like to show a quick demo on how do we run a generative AI application within few minutes. So that's what we're going to look at it. We'll understand the power of generative AI, the power of agents, and then we'll get into our course understanding. Just give me a second. I'll share my screen. I hope you are able to see my screen. You should see a workflow. If you're able to see my screen and you see a workflow, just give me a thumbs up or say yes. Perfect, perfect. Thank you. Thank you for the response. So what I'm going to show right now is quickly jump into the work rather than, just getting into theory and so on. What I generally like to do is run a quick test and show you this application, and then we'll discuss about the application. So once I start running this chatbot, it says that welcome to Tata Hospitals. I'll help you to schedule a meeting with Dr. Sai Kumar. Okay. Then it says, what would you like to book? What day would you like to book your appointment? I will respond with a very natural language response. So I'll say like, I am having a bad ache. I would like to get an appointment immediately. Okay, just don't worry about the spellings immediately. Okay, so when I said that, then it gave back a response saying that we have availability on 26th April, which is today. So I'm on India time zone. So it says 26th April, 9 a.m., 1 p.m., and 4:30 p.m. So I'm in a session, but I am having stomachache, but I would like to book an appointment at 9 o'clock. I'll say that, can you book it at 9 a.m.? I'm saying, can you book it at 9 a.m.? Then, it is doing some backend calls. Forget about what it is doing. We will again do a postmortem of what is it doing. But just it responded saying that, great, can I get your name and email address? So I'll give my name. Okay, I am Sitaram, and my email is, I'll give a dummy name, Sitaram at abc.com. Okay, so this is my dummy email address and my name. So I say I'm Sitaram and my email address is sitaram at abc.com. That's when it does something, say that, awesome, your meeting is scheduled. I have sent a confirmation email to my email address. This is not my email address, but I hope there is a company called as abc.com. I think I remember there is an ABC News channel. I'm not sure whether their domain is abc.com. And if there is somebody with Sitaram at abc.com, then they will receive an email. Right. So great. What I'm trying to show you that what has happened. Okay. So if you like look at the workflow I've created, so this is a open source tooling where we can create a quick workflow which is powered by generative AI. And this is called as creating an agent, where the agent will use generative AI and will have an ability to call any backend services. It can be a web service, it can be a database, it can be some verification system, or it can call an LLM. LLM is large language model. Please bear with me if you don't understand any of these terms, you're not understanding what's happening, just follow along. The reason is because during the course, we will spend good amount of time to understand how do we construct these kind of systems. Okay. So first things first, we will start with this message. We'll say, welcome to Tata Hospitals, and I'll help you to schedule a meeting with Dr. Sai Kumar. And once it is done, so there's no check. So it's once it is successful, it goes to the next message. That's the reason. It basically internally is doing like, what is today's date? So that's what it is getting, the today's date. Now this is um, it's working on the America Toronto time. That is the time zone. Then it says like, what day would you like to book your appointment? Then I give my message. I didn't give my date, right? So I didn't say date. I just said appointment immediately. So whenever is the next available best time, it should come back with that best time, right? So this is what my last utterance was. Last utterance is this line where it is trying to understand that when should I book the appointment? And then it is doing some crazy backend calls. So I have opened up a logging. So it is giving me all the details. One thing which I looked at is, okay, it is calling a model called as GPT 3.5 Turbo. Now, GPT 3.5 Turbo is the OpenAI's LLM model. It is calling that and it is trying to get some information. So it is trying to understand that, okay, we have availability on this. This is the response. So it basically said that, okay, boss, looks like there is an urgency, and that is done internally to the LLM model. And then it is coming up with the latest available times. Now, this can be plugged into a agent which basically manages the time or the manages the schedule of the doctor. For example, I have something like a Google Calendar or Calendarly or any other scheduling system where I can block doctors' available times. Then it can come back with the exact available times of the doctor so that I can go and do the next processing. So it come back with this message. Then I said that, okay, and it is asking whether does that work for you? And I said that, can you book it at 9 a.m.? So it passed from this stage and it is going to the next stage where it is trying to summarize the previous one. So this is the summarization, and it's getting like the trying to get the times, like does any of those times work for you? And then it is trying to collect the selected time. So what is the selected time? Is 9 a.m. from my utterance. Can you book it at 9 a.m.? So it doesn't require can you book it. So it has to exclude all that information and has to get only the 9 a.m. And then once it gets the selected time. So if I go through the log of this, then it says that entity extraction captured selected time. And if you come down, then the user has requested an appointment at 9 a.m., which matches to the available times provided earlier. The entity selected time is fulfilled. Okay, so what it says, it is doing the check. Why is that check? Because it has provided the available times 9 a.m., 1 p.m., 4:30 p.m. Imagine I would have told 10 a.m., which is not available here. Then it could have again asked me a message saying that, do you think 9 a.m. would work for you or 1 p.m. would work for you, right? So that is the internal loop which would run, and it will try to fulfill. So that's the rationale it has provided. The user requested an appointment at 9 a.m., which matches the available times provided earlier. The entity selected time is now fulfilled. So it then finally gets the selected time. So as you see, selected time is 9 a.m., which is again converted into some date and time. So can I get your name and email addresses? So it is again asking it has got the selected time and is going to the next service where it is trying to get the email address and the name so that it can send an email and a confirmation. So, and I responded again, what it has to do, it has to capture exactly my name. So it's the first name, last name combination. I have not given that my name will be in the first name, last name combination or anything like that. It understood that, this after I am, that will be my name, and after my email is this email address. So if I go down, it understood the extracted entities is Sitaram at abc.com and name is Sitaram. So it has understood all those things. Imagine I have not given one of the details. For example, I don't give email, I just give name. Then it would have asked me, Sitaram, could you provide your email address? Right. So it would stop here. It tries to poke me again, saying that, can you provide me your email address? And then once I provide my email address, that's when the confirmation happens. Now you might have questions saying that, Sitaram, is this a workflow? Is this something an open source? So you can go to create voiceflow.com. So this is the website, voiceflow.com, and you can create your own similar kind of a workflow on something which your business does or anything like that. Now you can create an open source one, but when you really wanted to use it, you need to pay the voice flow. But as you see, it's a very quick and easy way. It's a very easy way to create a workflow. Imagine there is a workflow within your company. You can create it, and you do not need any great generative AI or agentic AI knowledge. You should be able to do this. But now the catch is, imagine that you don't want to use the voice flow. You want to customize this entire flow. You want to know the underlying details of how does this LLM works? How does it summarize? How does it gets the selected time? How does it does something called as entity recognition? And then how does it integrate with different agents, and it has the ability to call agents based on natural language processing. Imagine I want to call a database in my backend. How do I do it? Imagine I already have existing APIs of my functionality, and then I just want to extract information from the natural language text and then call those existing APIs, get back the results. The APIs can fetch me some data or do some underlying DB updates or anything. How do we do it? If that is a question, that's where our course is going to help you, where you would be understanding right from the very basics. We will start understanding from Python. We will learn about how do you do Python for data science. Then we'll slowly navigate into something called as machine learning, which is the classical machine learning. The core of your machine learning will be learned, and then we will be graduating to natural language processing, deep learning, generative AI, RAG-based processing, and agentic AI. So that is the structure in which we will be moving. So this would be a 2-month exploration, and you have to dedicate every day 1 hour for this particular course, and it would be a weekday course right from Monday to Friday IST. And once you dedicate that time, you should be able to get the best out of this course. Okay, so just a brief introduction of what we are going to learn. If you have any questions, I would like to take a few questions now, and then I'll jump into my natural way of dealing with the content. Any questions? Or else you can give me a feedback. Are you understanding what we are discussing? You following along? Yes. Put it in the chat window, no problem.
Can we create another workflow?
You can create any number of workflows, yes.
Yeah, I joined a few minutes late and I did not see like how it got started.
Okay, so apologies, because if I repeat, this recording will be shared with you. But if I repeat again, it will be boring for everybody else. But let me give you a quick brief, okay? So I was talking about a workflow creation. I have not created this workflow. I already had the workflow created, so I did not start doing it, spending time. But just this workflow is created. It is a chatbot for booking a doctor appointment, and I was explaining like how it goes to different phases. So I would recommend you guys to go through the recorded video, and you should be able to get a good understanding. All right.
Hi, Shrikant. So this course content will help you create a model and train the model also, or
Yeah.
we are using existing model and we are trying to implement it.
It help you to build models from scratch. It's not just existing model usage. Of course, we will learn that as well. Like how do you do something called as transfer learning? How do you do existing model utilization and create applications on it? But it will also help you to learn different algorithms and how do you create models from scratch.
Okay. Yeah.
Okay, then. So
So
next,
is
yeah.
something can implement on UI part also? So back end and it's not DB and API part. Can we have anything on UI part, user interface?
UI also, but you will have an integration required for UI. Generally, if you see machine learning, data science, generative AI, those are backend technologies which help us to do predictions. But
Yeah.
this one will also be, we will not be creating UI for it, but imagine somebody already knows creating UI, say like they are React, Angular developers and all. They will be able to create UIs for this backend application. So we will expose these APIs. We will expose the models using APIs, and the UI can interact with the models, can do the processing. So that's how it will be done. But in this
Right.
course,
Thank
I'll
you.
not be teaching anything UI. I'm not a UI developer, so I might not be teaching any UI.
Yeah. Thank you.
All right then. So buckle up. I will start something called as end-to-end application of data science. So just a minute. I'll share my screen. Generally, what I do is I'll share via a notepad or a whiteboard kind of a setup. Let me share that. So it will be a blue board. I hope you are able to see the blue board now. So what we're going to discuss now is the practical AI engineering, or we can also call as practical data science. We are going to learn practical AI engineering. So I'll take an example of a bank. Generally, this example I take where we are trying to go back almost like say 20 years back, and then I take this example of a bank. Again, I give a bank called as ABC Bank. Imagine 20 years back, if we go and we are going to do any transactions with this bank. Typically what we do, we go and withdraw money, we go and deposit money. Imagine we open up a fixed deposit account, all those things. So typical transactions with the bank are interactions with the cashier or a teller, or maybe with the manager, opening up accounts, breaking the fixed deposits. And imagine if they provide some loans, then you would apply for loans. So these are all the typical transactions, but those are more manual in nature. We go to the bank, physically do these interactions with the client clerks, or the tellers, or the cashiers, and then do the transactions. So though all those transactions, typically the banking transactions, they used to store in something called as ODS. ODS is nothing but operational data stores. These are your regular RDBMS transactions. RDBMS. Your regular RDBMS, which are like the what do I mean to say, the the oracles, the PostgreSQLs, MySQLs, that kind of systems where typical RDBMS transactions are used, and we are trying to do this RDBMS kind of transactions. So what these RDBMS transactions will do is, typically when a cashier or a teller does withdrawal of the money or deposit of the money, that information will go to these ODSs, and then we'll save that information onto the ODSs. And if the bank has employed a data analyst or a data scientist to understand what is happening with the transactions. For example, bank want to understand more information on how many transactions happened, how many withdrawals happen in this day, how many deposits happen, how many requests came for applying for a loan, uh, how many fixed deposits were open, what is the amount of fixed deposits opened, and so on. So if these are all the questions for the bank, right? They employ a data scientist or a data analyst, and they run SQL queries. So they run SQL queries, and the SQL queries were run on these RDBMS tables. So when you run the SQL queries on the RDBMS tables, you can typically do a lot of these analytical transactions. Once you do the analytical transactions, and you can use those analytical transactions for creating some kind of reports or dashboards for the senior executives. So this used to happen 20 years back, and people used to run SQL queries, and it used to work very nicely. Typically, if you look at the business hours of the bank, they used to go from 9 o'clock to, excuse me, they used to go from 9 o'clock to 5 o'clock. So this is your business hours of a bank. And, uh, and when these SQL queries are being run, if they are run during the business hours, sometimes they used to have issues with the actual transactional transactions which happen to the ODSs, right? Because the long running queries run at the same time, and then it slows down the actual database because there are a lot many queries which are running during the business hours. So that with that problem, what people thought is, okay, let us not run our SQL queries during the day, but let us run these queries during the night. And that's when these nightly jobs came into picture. Nightly jobs are nothing but the jobs, the SQL queries or programs, which are run during the night instead of day. The reason is because they want to isolate the actual business hours and want to keep the databases active during the business hours, and then bombard them in the night so that they don't have the problem of slowing down the queries and all that stuff. And this used to work for a long time. So many people are familiar with nightly jobs. They used to also do supports for nightly jobs and so on. And this used to work for quite a long time. Then what happened? Two things which actually changed the way these jobs used to work. The first one is the adoption of internet. And I'm talking about uh, around 2000s, 2005, that kind of an era. Internet, adoption of internet, and the geographical expansion. So adoption of the internet, like how web-based systems have come into play, how mobile devices came into play, and there was no such lean period which says that in the night there is a time where you can run the jobs. Because if the websites have come into play, mobile applications have come into play, which has provided the users to access the bank transactions 24/7. There was no such period which says that, okay, this is the time where my bank is free. You can go and run your nightly jobs during that time. So there was no such lean period. We call it as a lean period, which is the time in the day where the bank's transactions are at the lowest or the lowest, so that people can run any jobs so that they can do some analysis. So at internet, and the second one is geographical expansion. Geographical expansion means that a company in US, for example, McDonald's in US, has opened up its operations in other parts of the world. For example, it has opened in Dubai, it has opened in Australia and Singapore, India, UK, and different places. So when this happened, what happened is that there was no, again, the lean period, because the business was happening throughout the clock. Right? There was no such period saying that, okay, US is not operational, but you have Dubai being operational, you have Singapore being operational. So because of these two reasons, the internet expansion and the geographical expansion, uh, we were not able to run the nightly jobs. And that's when the concept of data warehousing came into picture. You might have heard about data warehousing. It's typically called as DWH. DWH or data warehousing systems. Now, what the data warehousing systems ideally got into play is that they were decoupling the operational data stores and the warehousing data stores. So they were decoupling the basically the ODS is decoupling. You can call as so they are decoupling the actual tables with respect to the warehousing tables. And they use a process called as ETL, extract, transform, and load. Extract, transform, and load, what it does is it extracts the data from the operational tables. It does some transformation. Imagine it is extracting from multiple tables. It has to combine all the tables. Then it has to transform and then load it into a warehousing table. A warehousing table, you can think like a replica of your operational tables. And now you don't have to run on operational tables. Now you can run those jobs on your warehousing tables. And there is no time restrictions because warehouse tables are not connected to any front-end systems. You can run your jobs 24/7, and then you can bombard with very powerful queries, long-running jobs, and all that stuff. It has given a great flexibility. The second thing it has given is great flexibility is that warehousing tables are capable of storing historical data. When you're storing historical data, you could do analysis like seasonality analysis, the comparative analysis, and so on. Imagine you want to compare this month's revenue targets with respect to last year's revenue targets, this month's deposits with respect to last month's deposits. Imagine you want to do this kind of comparative analysis. This is possible because data warehouses have stored those historical data. Now, data warehouses even today are very popular. There are a lot of jobs in place where people work on these data warehousing systems, and they typically do these ETL, maintain the data warehouses, understand how to create reports from data warehouses, and all that stuff. So those are the suite of jobs which are very popular even today. But one thing data warehouses do not have is they are not rightly suited for unstructured data. And if you see 10 years back or around 2012 to 2015, that time frame, the concept of big data came into picture. Big data is where you are not only storing structured data, like a table format data, but you can also store in terms of images. You can store log files, you can store textual data, you can store customer feedback, you can store videos, audios. Everything can be stored in something called as big data systems. Typically, the big data systems are housed by something called as systems like Hadoop, uh, Hadoop, and so on. But generally, they were given a name called as data lake. Data lake can be comprised of Hadoop, which is kind of an open source system, or you can take the help of cloud computing. So you have your AWS, you have Azure or GCP. So name it, you have our popular cloud providers, which are now able to store large volumes of data. You can create these kind of storage systems, and all this is possible because of these different storage systems. So with this, what happened is there is this large volume data processing started in place. And they are calling it as data lakes. Now you could feed a lot of, say, video data. You have an ability to store log files. You can store text data. You can store some sensor information. So something like IoT sensors and so on. So different types you can store, say, like music files or audio data. All this is possible now, and now we can store all this information into these data lakes. So these files can be structured as well as unstructured in nature. And there is a lot of responsibility here because we need to see like where the data is coming from, how do we ingest, what is the right format, how do we push the data into a scalable storage format. All this is possible, and this is done by, and this is called as data engineering. This is called as data engineering, and the person who is doing this is called as a data engineer, right? So what is his or her role? The purpose of the data engineer is like, okay, identify what are the different sources of data, how do we ingest the data, how do you create compute instances, how do you do data transformation, and then do some kind of transformation from raw data to a transformed format. All those things are pushing into these systems, right? So that is how your application systems are working, and then once the data is ingested, now we have a proper raw format data available here. The next step is to analyze this data, right? So people do something called as exploratory data analysis. The first step they do is called as exploratory data analysis, or in the shortcut, it is also called as EDA. EDA is the exploratory data analysis, where we are trying to use techniques like visualization tools like Tableau, ClickView. We could use like Power BI. We could use programmatic Python programmatic visualization libraries like Matplotlib, Seaborn, Plotly, Bouquet. So different tools are there which will help us to analyze data. The data is in a raw format in data lakes. Now we have to analyze the data and try to create some kind of meaningful observations in the data, so that you could do a lot of the analysis of what the data is going to, what is the data, what clues the data is giving, what is the data speaking about, how are the patterns within the data. So all this information is required because it will help us to analyze the important information and ignore unwanted information, right? So that is what we call as exploratory data analysis. Once a data scientist does the exploratory data analysis, they also do something called as feature engineering. Feature engineering. In the feature engineering, they create something called as feature stores or feature marts. Features are nothing but reusable components of your raw data. Once the data is pushed from these different sources, the structured sources, unstructured sources, and all of that, it is in a very raw format. What we need to do is uh, we need to condense it into a very meaningful, usable format. For that, the meaningful, usable format, which can be reusable by other data scientists, is called as a feature. For example, I am spending on my credit card. Imagine I spend every day on my credit card. Every day morning, I buy a coffee, I buy a lunch. Sometimes I fill fuel in my car. I sometimes do shopping. On the weekends, I go for movies. Imagine this is my regular spending on my credit card. If you see, there is every day there will be transactions. Some transactions will be few dollars, some transactions will be tens of dollars, and sometimes it is much more. When we are trying to do analysis of my credit history or anything like that, you do not really need everyday penny wise transactions. Okay, you do not need to know like I spent $1 on a coffee, then $2 on a bagel, $5 on a pizza. So I don't need all these smaller things. What we do is we condense all that information and then say, in a month, how much did I spend? Okay. If I have a grand total of my monthly spending, that grand total of my monthly spending is called as a feature. So I can condense all my information and then I can group them as a grand total. Or maybe I can do an average monthly spend. So that can also be a feature. So feature creations are important because you don't want to uh, just just bugged up with like small minor details. For some kind of analysis, we would require minor details, but generally we might need to condense that information into much more usable format, and those are called as features. Once we create that feature, then use that feature, we will do our AI system creation. Okay, we will create our AI models using this feature engineering. So there is a question that integrating banking systems with AI secure is safe. What if the unauthorized persons apply loan and integrate? So the question is on the security, right? So all these systems are clearly clearly guarded by a very strengthened data security system, right? When you consider banks or hospitals, insurance companies, data security plays a pivotal role. We have guidelines in which, like, who access data, who creates data, and who can access data. So it's a pure role-based data access. So imagine you have data IDs, for example, your employee IDs. Every employee will have these authorization to access the data, and then both are available, and both will be used for ensuring that the right people have access to right data. For example, somebody like a CEO can access everything, so they will have higher privileges. But somebody as a junior developer, they will not have access to production system. They will not have access to, even sometimes even they will not have access to the UAT systems. They might have to create some dummy data, try and test their models, and then eventually use a CI/CD process to promote their code bases to different stages and then test them accordingly, right? So it is very, very important to guard the data. And there are very robust systems which are built, role-based systems, which will help us to build that. So is the exploratory data analysis and the feature engineering different? They are different. Exploratory data analysis tries to create charts and graphs and so on to find out patterns. Those are more visual in nature. And feature engineering is like data data which is in a raw format gets transformed into a next stage, which is much more condensed format. And those we call as features, right? So this is more code based and this is more visual. Exploratory data analysis is more visual, where feature engineering is more code based and typically used for creating lower level features, which will be used in my central piece, which we call as modeling. Right? So modeling is where you uh, features means features are not KPIs. They are the reusable, as I said, right? If you have amount as a column, okay, in my table, I am using amount as a column, and every day the amount is getting information. Uh, Instead of taking amount as individual column, can I aggregate and create a average monthly amount? That is a feature. Imagine my database column is amount. From amount, I am creating average monthly amount, right? This is a feature. Got it? So it basically like aggregation of your information. You don't have to use amount as a column. I'm just giving an example. There's a lot of feature creation, which is like overall aggregated information, and that will be used for your AI modeling. It is used for your machine learning system, right? So in the modeling, you have multiple algorithms which we will be learning. There's supervised machine learning. There is unsupervised machine learning. and there is reinforcement learning, or basically I'll use the generative AI here. There is the generative AI. See, all these systems, they come as a part of your central package, which is called as modeling. Modeling is, given my input data, I already have some patterns. Using that patterns, I want to create future predictions or future generation of data, or kind of creating grouping, doing recommendations. So all these things fall under this modeling. Modeling is a bigger piece. We will spend a decent 1 month time understanding different modeling techniques. How do we derive different modeling techniques like supervised, unsupervised, generative AI. Within supervised, we have classification regression, we have clustering, hierarchical clustering, k-means clustering, different types of algorithms are there. We will learn all those things. At this moment, you might be getting overwhelmed with all these kind of things, but just understand that modeling is a central piece which helps us, which helps the data scientist to build AI models, and which will be used for doing future predictions. A future prediction can be, okay, I got my amount, I got my all the details for predicting a loan eligibility. Okay, so I collect what is my salary, what is my bank balance, what are my different liabilities, do I have loan, do I have a EMI to be paid, am I married, do I have kids, and all these information goes as features to the model, and the model will predict whether I am eligible for a loan or not, right? So that prediction, the machine is doing that prediction where it is determining whether I'm eligible for a loan or not. So that is done by your AI model. Many a times it is unfortunate that people only give a lot of preference to the modeling, even in academics, right? So if you have done any computer science degree, if you have done the machine learning becomes one of the course, and then in that you will be learning different algorithms. You'll learn tons of algorithms, and then end of that algorithm is like some kind of accuracy which says that how good that algorithm is. And many institutes or many of the educational institutes also try to only talk more about modeling. But important thing is we are here to understand about applied AI. Applied AI in sense, uh, how do we apply this model? How do we take this model into production? So the modeling because becomes only a one piece of the Lego block. It is not the entire AI, but it is just one single piece of the Lego block. We also need to understand not many other things. For example, after the model is created, how do we deploy the model into production? This is a very important, very important piece, and many people do not know also, because that's the reason 80% of the AI models are only in the POC stage, because they don't end up into a deployment stage. So once a model is created, a model you can think like an executable of your analysis. Once the model is created, we need to know like how do we deploy it into production. So there are two deployment methods. One is called as a batch deployment method, and the second one is called as an online deployment method. A batch deployment method, you can take an example like every day the bank is collecting applications of people who want to apply for loan. During the day, it will collect all the applications of the applicant who want to apply for loan. So they collect their bank balance, they collect their annual monthly salary or annual salary, they collect all the liabilities and all the details, and then they create a file, and the file gets fed to this batch processing in a batch based mode. Imagine there is a scheduler which runs every day 9 o'clock in the evening, and the scheduler gets the file, and the batch program will trigger the model. Imagine this batch is running in a cloud provider. Imagine I take this as an AWS cloud provider. and this cloud provider will have the model, and the model will be run using this batch program. So there will be some kind of a scheduler. You can have autosys, you can have airflow, or any type of scheduler which is scheduling this job, and this job is running every day at 9 o'clock. And the purpose of this job is it gets records of all people who applied for loan during the day, and it needs to create another file, approval file, which will have all the people who have applied and the status, whether the loan is approved or rejected. Imagine 100 people applied, then it will give an output file of all the 100 people with their loan approval status, whether it is approved or rejected or withheld or any other status, right? So it will give that prediction, and that prediction goes to the downstream systems. Now, this batch can be scheduled in a way that it does the predictions and then it creates a file. That file goes to the downstream system. The downstream system can create application IDs or maybe send emails to the applicants who got approval, right? So imagine I applied for the loan. I will get an email saying that, congratulations, Sitaram, your loan is approved and you're getting so and so loan amount. Please click here for acceptance. So you'll get like an email directly in your to your email. So that is basically called as a batch-based process. There is another thing called as online process. Online deployment is where you're creating something like APIs. So you can create an API, and this is a real-time API. That means that I can invoke the API, and imagine I am invoking it from a web system. So I have created a website, and the website is collecting a lot of information of the user. It is connecting the age, the marital status, the bank balance, and all that stuff. And then it has the submit button. You can submit the loan in real time. And then imagine this is abcbank.com. So you can go to abcbank.com and fill all the details, and you will submit the submit button, which will invoke the API. And the API basically will have a model in the backend, and it will give result in a real time. So as and when I am keying in the information, I am pushing the submit button, it will go and invoke the API and it will get back the results. This is what we call as a online deployment or a REST-based deployment. Understanding all these things is really important, because here we get to know something called as machine learning operations, ML ops. We call it as ML ops. And we use generative AI, we call them as LLM ops. How do we deploy generative AI applications? How do we create agents and all that stuff? We'll be learning in these two things, called as machine learning ops and LLM ops. Once we have done the deployment, another important thing which many people don't learn is called as monitoring. Now, what is monitoring? So once my model is deployed, I need to monitor the model throughout the life of the model. Imagine I deployed the model in, say, January. Now I want to see how the model is working right now, right? So what is the health of the model? Is it performing the same way as it was created during the development, or is it deviating from the targets? All those things. That is where that is what we call as monitoring. So there are two important concepts in monitoring. One is called as explainability. And the second one is called as fairness. Explainability and fairness are very, very important. Explainability talks about how, if you are taking any decision using this AI model, on what basis did you take the decision, right? What are the clues or what are the reasons you have taken the decision? Imagine I got my loan. On what basis I got the loan? Is my credit score good? Is my average monthly balance decent enough? Is my spending right? All those clues are important. So the model needs to understand, give weightage to the features which basically has given a decision making of getting to a final result. So that is the explainability concept. And there are a lot of metrics we calculate for identifying the explainability. And the second one is the fairness. The model should not have any bias. For example, I apply a loan and my wife applies the loan, and both of them have same educational background, same lifestyle habits, and similar kind of job roles and salary ranges. And imagine I get the loan and she doesn't get the loan. That means that the model is not fair. The model should not have any bias with respect to demographics, caste, creed, or any kind of discrepancies. And the model should be fair for all conditions. So that is called as the fairness. So we need to identify the explainability as well as the fairness-based metrics. And those metrics will help us to gauge like how is my model performing and how good the model is. And last but not the least, we have something called as AI governance, or generally we call as AI protocol. And we call as AI governance. And then AI quality. This is where we keep track of like how my model is performing, what is the ROI of my model, uh, is the model having proper quality checks and all that stuff. So it tries to get all those information, and it ensures that the AI model, whatever we have built, whether it is supervised machine learning model, classical machine learning model, generative AI model, uh, different types of models are there. Depending upon the type of the model, we try to ensure that it is having the proper quality assurance checks. It has the proper governance in place, and especially the governance with respect to sharing of the data, usage of the data, and sharing of the results, and all that stuff falls into this place. That's what somebody was asking the security question. So here in the AI governance, we ensure all those things are considered, and then so the final application whatever we build is foolproof, right? That's what we do. All right, so we spent a quick half an hour, and I'm sure the screen is filled. Pardon me with my handwriting, but I'm very confident that by the end of this course you'll understand my handwriting. So that has been the case with all my previous batches. So with that, I would like to give a quick 5 to 10 minutes for anybody. If you have any questions, you can ask. So this is Sitaram, and I have close to 20 years of experience in AI, data science, and machine learning. I currently work as a senior vice president for one of a large banking corporation, and teaching is my passion. I'm doing my doctorate in AI ethics, fairness, doctorate, my PhD, and I do this as a side gig, and that's my qualification. So I hope you liked the session. If you have any feedback, questions, I'll be here for another 10 minutes. Please do ask. Thank you.
Good morning, Sitaram. Myself Srinivas Gopal. I have few queries. So when we are going to learn this generative AI, so it is must and should that we need to have a complete understanding on the modelings. Like for example, for supervised, unsupervised, and generative AI, there are multiple number of algorithms are there. So we
Yes.
need to have a thorough understanding of each and everything, or just the basic concepts.
So there are different algorithms, as you rightly said. Just a second. So as you rightly said, there are a lot of algorithms which are available. And if you go learning all algorithms, then it will take a lot of time. What we need to know is we need to have this distinction. We have something called as classical machine learning, where we talk about regular classical machine learning algorithms. We will we will learn the best best breed of algorithms in that space. Okay. The classical machine learning is important because that is what is bringing money to the table. At this moment, the classical machine learning models like predictions, fraud detections, and all the stuff, those are called as classical machine learning. They are actually bringing the revenue to the companies. Generative AI has a good amount of hype at this moment, but the realization of business benefits is yet to come. So people are experimenting, doing POCs at the stage, trying to see like how do you build agentic systems, generative AI systems, LLM based systems, and so on. So we'll understand that, and then we'll also poke into like how do you really bring business out of the technology. So that will be the focus of the generative AI part. But if you really wanted to bring business, learning the classical machine learning will help us get more details. So we will mix both of them, and during our course, we'll learn one after the other, and we will concentrate on important items, right?
Okay, but basically for an data warehouse data engineer or a data scientist, so nowadays everyone is using the Chat GPT or some other LLM tools. So people says that no need to go deeper inside the technology and the implementation. Just understand that how much the prompt you give to the LLM mission, so that the how efficiently that gives you the response, and how efficiently it gives the response by decrementing the cost of giving the response. So those
Yeah,
type
yeah,
of
yeah.
answers will be coming from them.
Correct. Correct. You are also correct here. See, what I strongly believe is people should have fundamental idea of how do we do things. Okay. If you understand that what is the blueprint of modeling, how modeling should be done, and what are the available possible options, you do not need to, as you rightly said, people do not need to mug up the what I mean to say, the coding syntax and things like that. You might not need to know like what are the different parameters used for algorithm also. And with the help of generative AI, you might have heard about the term called as vibe coding. Vibe coding is the one which helps us to use the help of ChatGPT like LLMs and help us doing coding. So that is going to be the norm for the future. We certainly need not mug up all those patterns, all those coding practices, and so on. But we need to have a decent understanding of the blueprint or the framework, or how do we do things. So that is where we need to have a decent understanding. And even if I want to direct the chat GPT with some prompt, I need to know what prompt should be given. What is I am intending to create, or what is I am intending to solve. So if I don't give that right information, then I would end up with hallucinated results, and which will not help me to go any way further. Right? I will be in that loop. Okay. So this course will help us to understand the foundation and understand how do we build that base for creating AI applications. And we will also see like how we take help of ChatGPT or likes of it to create our code. We will get into something like Google Colab, where we will see the examples of generative AI, and we will use that. So that during the course we'll understand that.
Okay, okay. And last doubt I'm having is the feature engineering and the exploratory data analysis. So basically, when we are creating the data warehouse, we'll be creating something called data marts or something. So it is nothing but the raw data which is coming from the OLTP system that is
Hmm.
being transformed as per the business logic, and it will be stored in the data marts and data warehousing. So finally, the conclusion is the data warehouse will come contains the complete meaningful information about the data. So on top of it, we will be creating the reports by using Power BI, Tableau, something. So
Correct.
here, the first step is exploratory data analysis. So here, as you mentioned earlier, we'll be using the Power BI, something visualization tool to give the insights of the data. So it's just same way. exploratory it means something
Yes, yes.
else.
Exploratory data analysis is exactly same. So some people do not have the background of what you have just spoken, right? So
Okay.
that's the reason I'm giving this information. But yes, whatever you said is correct. So we need to, once the data is from a raw format to a very transformed format, you then again need to analyze the data, create some reports, charts, comparisons, and all that stuff. That comes under exploratory data analysis.
Okay. Now coming to the next one is feature engineering. So in the feature engineering, so based on our, for example, based on our requirement or maybe some understanding about the project, we need to create the identify the list of features of the model, or it's
Yes,
what it
yes.
means exactly. I didn't
Exactly.
understand.
So that is correct. So based on our understanding, based on the business insights, we need to create features which can be reused. So I create features which can be reused across my team. So that's where, so sometimes data marts itself can work as features, right?
Mhm.
If the data marts are very condensed, they have created more meaningful information and available, then we can use them as features. But imagine those are not created, and then feature engineering or feature marts will be created, which are similar to data marts. Okay. But those are the ones which have more condensed information, more meaningful information for doing analysis.
Okay, but basically the input for exploratory data analysis and feature engineering both are same only. It's
Both are
nothing but the dimension tables and fact tables and the
fact
respective
tables and
views.
dimension tables. Yes.
Okay, got it. I'm clear. Yeah.
Any other questions?
Hi, Sitara.
Hi, Ram.
So, in this content, we are using we are talking about, we are going to talk about vector TV also, or we are strict with this SQL and all.
So we will not spend so much on vector DBs. There are a lot of vector DBs currently available in the market. We can use one or two. There is Milvus, there is ChromaDB, and things like that. So we can use one of the vector databases to create vectors and use vectors. So we'll cover something called as RAG, which is retrieval augmented generation using LLMs, which would
Mm.
require data to be pushed into vector DBs and then read it and then create more meaningful summarized output or question answer systems and so on. More contextual knowledge of enterprises or business. So in that, we will be doing that. Creation of vector DBs and using RAGs for retrieval.
Okay. And we are talking about this cloud, right? Cloud integration.
Yeah, we will
So
use
there is AWS or Azure also.
we will use
We use.
AWS. AWS is the industry leader. I have good expertise in AWS. But whatever we will be learning, it is kind of general, right? So I'll not be teaching like how do we spin up instances on AWS or Azure or all that stuff. So that is more into cloud-based engineering. What we'll learn is like, imagine I have an application, AI application. What are the things which are required for me to deploy into cloud, right? And that can be any cloud. You could deploy into AWS or Azure or GCP. It doesn't matter. Pretty much the process would be same. Just the tooling names will change or the mechanisms in we deploy might change a little bit, but everything else would stay the same.
Okay. So one last question. So by end of this course, we are very confident to build a model and train the models, right?
Absolutely. But I need your 100% commitment. I am 100% committed to make this course a very power packed practical course. I want you guys to bug me every day, try to do the examples, what I do every day. So this will be like, we will not be using any presentations. Most of my sessions will be like this blue board. It will be very extempore. Imagine you ask questions, then I'll keep adding flavors to it and so on. So I'll make the conversations uh, more interactive. And there will be every module will have some kind of assignment, some kind of homework kind of a thing. I would expect you guys to take that and practice during your free time. So that is the expectation I have. And once you do it, I am very, very confident that you'll get the best out of the course.
Okay. And I have seen the content, and there is a couple of real-time tasks which we are going to implement. We are going to implement all the, or we are right? Are not going to skip anything in that.
Yeah, yeah, we will going to implement all of them.
Okay. Yeah. Okay. Thank you. I'm good from my side.
Any prerequisites are required, Sitaram, before start of this modules like
Understanding of language, programming language is important. It doesn't matter if we will be using Python, but understanding of Python or any other programming language, Java, .NET, C++, programming language is important, because I'll not be teaching anything like, how do you create variables, how do you create functions, what are the programming constructs, all those things. I am assuming that you guys know. Again, this group might have multiple people. They might be coming from different backgrounds. But irrespective of that, I would like to have you guys brush up those understanding, like how do you really create programs and so on. And during the course, we'll be learning Python for data science. That means that Python becomes a basic language, but we need to see like how that language libraries are used, how we use for creating models and all that stuff. So that you will get very comfortable doing it. But external things, you have to do a little learning.
okay. And earlier there was a question that RAG means acyclic graph, like which is used in Databricks.
No, 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 no. That's a different one. That is cyclic. I
Yeah,
forgot the full form of that RAG. Directed acyclic graph.
yeah, yeah.
That is DAG, directly acyclic graph. That is different. RAG is retrieval augmented generation, which is a part of generative AI.
It's just like a, for example, if I'm going to give one prompt, I need some requirement. For example, I have a requirement from the customer that use this Excel file to read this Excel file and perform some operation on top of it and give some results. So if I wanted to give to the LLM mission, so the LLM mission will type it. After that one, how this prompt data will be read by the system, and how efficiently it gives the result. It's like a the processing graph, like that it is same similar like that.
Yeah, yeah. So imagine your company has some policy document, some 1,000 page policy document is there.
Okay.
And now I have to ask questions on that policy document. Now, the process in which I push this policy document into a backend database, typically they are vector databases. And then the LLM can read the vector database, give me the exact answer to my question. Suppose I have a HR policy document, I push it into the system. The RAG is a process in which I create the intelligent retrieval from those documents.
Oh,
And
got
I
it.
can create it locally. I don't have to push it into cloud, because this can be very proprietary and things like that, right? So I have to create my local system so that I don't compromise on the data security and other stuff. And then I create my own local intelligent answering system. That the process of doing this is called as RAG.
Yeah, similar to the finding the efficient path from start to the end. Yeah, similar to the database. Okay, got it.
Yes.
Yeah,
That's a different problem, but yes, something like that. Yeah.
something like that. Yeah, got it.
All right. So generally, our first few sessions will be a little extensive. You'll end up spending 1.5 hour. 1 hour is a direct every day. We will spend 1 hour for our course. But the first few sessions, there will be a lot of questions. People will have a lot of doubts. So I would request you guys to bear with me. It will be your night time, but you have to let go your sleep for half an hour more. So half an hour will be our target, 1.5 hour maximum, I would say. So first few sessions, you will see these kind of sessions, because I encourage people asking questions. So eventually I'll say like use of chat, okay, is much more recommended. Because sometimes what happens is the questions interrupt the flow. So I would recommend to use the chat. And sometimes you can't ask question in the chat, then you can stay at the end, probably note down the questions, and then we can discuss in the end. I'm happy to spend extra 10-15 minutes also. That's not a problem. uh, I will say that, okay, course is ended. If anybody wants to have questions, they can stay, others can drop off. So they can sleep and then they can wake up in the morning, go back to their regular work. So this is our regular trend. With the experience, I've seen that first few sessions will have more questions. Eventually, as they understand, they get a more feel of the delivery and all, the questions slowly fizzle out. I highly recommend to use chat because it becomes very easy. I can blend the questions during my session, and I'll pick the questions which are important and blend them during the course itself. All right. Any further questions? Or else we can close the demo.
I hope we are good.
Thank you very much, and thank you for joining the demo. And I'll hope you liked it. And looking back to see, I think the course starts from Tuesday, 29th of April, 7 a.m. to 8 a.m. That's the timing. And do reach out to the organizers. They have put a message in the chat. Reach out to them for any questions, details, and so on. They'll be able to answer all the queries. Till then, take care and have a nice weekend. And I'll see you on Tuesday. Thank you. Bye.
Thanks,
Thank
Vikram.
you.
Have a nice weekend. Bye bye.
Bye.